For new energy, Taikan can currently provide you with a one-stop solution. First is machine tool selection. We provide customers with the best solutions and the most cost-effective machine configurations. We also offer automation solutions, which we'll introduce later. This is a real-life automation plan filmed at a customer's site. We can also provide turnkey services because many customers might be unfamiliar with the product. Taikan has a very strong technical team. For turnkey projects, we provide the full set: tools, fixtures, programs, processes, and equipment. This is our Division 1 gantry machine tool, used here for a rear base plate case. It has a large tool magazine and a 5-axis swivel head, making it what we often call a pentahedron machining center. This machine structure is large and has a square design, which is excellent for processing square parts and offers great value. Regarding battery trays in new energy, since these parts are typically long, narrow, and low, we developed this G2500 profile machining center. Its key feature is an exceptionally long X-axis travel of 2.5 meters with a Y-axis of 400 millimeters, making it highly advantageous for long parts. Our automation solutions come in many forms for the machining process, including ground rail, overhead rail, and cell-based automation. Because Taikan has a wide range of products, we can basically cover the machining of all common new energy vehicle parts on the market. Customers only need to provide drawings and blanks. We then provide the corresponding equipment, tools, fixtures, programs, and process routes, the entire package. Let me introduce some typical cases for new energy vehicles. You can see several major components: power components like motor housings, axle components like steering knuckles, frames, transmission parts like gearbox housings, and brake components like calipers. For motor housings, this is a solution we use at a customer site. It involves two operations. The first uses our Q7, a high-speed horizontal machining center. With 5 axes, it can machine 5 faces to complete this surface. The T8 is a vertical profile machine with a high torque spindle and excellent rigidity. The Q7 actually features a gantry frame structure and utilizes 5 axes, as this part requires many holes and extensive machining on the sides. This subframe was also done at a customer site in Jiangsu. It uses our H1560, a 5-axis horizontal machining center. This machine is quite large, with a travel of about 1.5 meters. I believe it has the lowest cost in the industry, making it perhaps the most cost-effective machine. This is an oil pan. This case uses the newly launched 856S. With a 4-axis rotary table holding 2 parts, this solution shortens tool change times and boosts efficiency. The machining time per piece is just over 3 minutes. This is an electrical control box housing also machined on our 856S. Operations 1 and 2 finish the datum planes on both ends, while Operation 3 uses our Q7's B-axis to machine the perimeter. This is our electric drive housing. It has a large surface area and requires extensive machining. This type of work needs a through-spindle coolant system, otherwise chip removal is difficult. With the throttle body, we load 3 parts at once. This ensures the best possible machining efficiency and stability. This part is even simpler, also using our 856S. In terms of stability and value, it's a flagship product on the market. This is a clutch housing. For new energy vehicle machining, the first operation uses a V856S with a 4th axis for the bottom and datum surfaces. The second uses an S8 and finally OP30. Why did we choose 4th axis machining? It's mainly to balance the cycle time. If the 3 operations aren't balanced, some machines will be very fast while others are very slow. By adding this 4th axis, the cycle times for all 3 operations are consistent, making line layout much more convenient. This is the transmission front cover, the lid for our gearbox housing. The first operation uses this bottom surface for rough positioning to machine the top surface and side holes. The second operation uses our V856S for the next step. In all the plans we develop, we actually try to shorten the machining process steps as much as possible. The fewer the steps, the more stable our process management becomes during production. More steps and more intermediate setups will negatively impact our overall machining quality.